This printer is capable of printing the world's softest filament ×5. But there is a lot more to the story, and therefore we have to go back in time a little. This is the start of a big project funded by the Northern Netherlands Alliance, who is a management authority for the European Regional Development Fund. So yeah, I'm getting paid by the government now. And what are we going to do with that money? Well, we are going to completely f*** up this. We are going to print the weirdest, most interesting materials. Yeah, good. This is going to be a tough retake. Yeah, could you maybe send me another Excel? Yeah, I tried to record that segment of removing the box and I kind of messed up. Hello? We are going to print and combine the weirdest, most interesting materials we can think of. I'm not talking about materials like ABS and TPU. I'm talking about materials like foam, epoxy, glue, concrete, resin. It is an FDM resin printed benchy, just to name a few. So a lot of experiments I did in the past will be revisited during this project, but level it up a bit. Ooh. So the goal here is to see what's possible and which new use cases we can find. Think of this Prusa XL as our experimental platform, our blank slate. We can do whatever we want with it. The official project name in my communication to Prusa is the Fuck Around XL. And I pitched this idea to Joseph a while back while being shit-faced drunk in England. And apparently I said something right, because, well, here we are. This is gonna get messy, this will be dangerous, but most importantly, this is gonna be fun. The idea for this video is not to place these 5 tools on the Prusa XL and call it a day. The idea is to replace the extruder that comes with it, so the next extruder, with the latest version of the Proper Extruder. I started the development of this extruder already some years ago, and in the beginning of this year I had an intern, his name was Wessel. He also went with me to Ivan Miranda to make the treadmill printer. But his main task was to continue development of this extruder, to really focus on improving the performance, and he went through some iterations and eventually managed to hit some really interesting numbers that we never expected to be possible at all. It was especially interesting with extremely soft filaments. So for me there are 2 reasons of doing it like this. First reason is that this allows me to print extremely soft filaments on the Prusa XL. And the second reason is that if I manage to make my own extruder for this, to make it fit on the XL, then this would open up a lot of doors for all the other experiments. So yeah, I'm going to take this thing apart and see how this next extruder looks on the inside. I really like taking up a project like this completely blank. I have a rough idea of how this printer works and what to expect from the inside, and therefore I'm confident that left or right I will make this work. But it's always exciting to figure out what's inside and how we are going to approach a project like this. Okay, we've got a bit of a challenge. The thing is that we have a tool here, and in order for the printer to detect the height, it uses a load cell. Once the bed touches this nozzle, then it sort of flexes and it can detect it. It's not like some of the old printers where you use a micro switch. It actually uses the nozzle. And I think that's a really smart design done by several manufacturers already, and I'm pretty sure they all took it from my idea years ago. I took it apart, and if you look closely, there is this load cell here, but it's glued in here. What it does is that this part, it flexes. Okay, I fully reverse engineered this part to show you how this works, because this is important for understanding the rest of the video. These 3 holes are fixed, and during homing, a small force is applied at the bottom where the nozzle is placed. If we run the simulation, you can see that the part flexes. This is greatly exaggerated, but shows how it flexes. It's pretty cool that this part has multiple functions, and I've got to say that this is some clever design. The load cell is placed on top and flexes with it, and this part changes electrical resistance when flexed ever so slightly. This is then measured by the 3D printer controller. What if we use this as our way of mounting tools. If we mount this tool to this flexible side of our load cell, then what I'm hoping is that this is stiff enough for the load cell to detect it homing. And if that works, we can mount all the tools that we have. We can just mount whatever extruder to this part, and then the whole homing sequence should work. I scanned the plates on this two-dimensional scanner, so I could use this as a reference for reverse engineering them. I designed a simple bracket that is placed between the two plates and printed it the next day. The existing screws are replaced with shorter ones, so I can use the existing threaded holes to mount that bracket. That load cell is then mounted to it, and we have our base plate now to mount our tools to. I started with designing the bracket for the Proper Extruder and used one of the existing tools to figure out how high the nozzle must be mounted. This was a very simple design, and I mounted that to our base plate. The Proper Extruder uses a Bambu Lab hot end because of the small footprint. And fortunately, in the last video, I found a way to modify this so it fits E3D V6 nozzles. This is compatible with the hot end that the Prusa XL uses. So I took that hot end apart and mounted the heater block of the XL to my modified Bambu Lab hot end. This way we can use the existing heater cartridge and thermistor. The last step was to mount the electronics board somehow, and because I couldn't find any CAD files of it, I decided to 3D scan it. This way it's easier to design something around it because of the connectors and higher components. This was a very difficult part to scan though, and I couldn't get a good enough scan. So I had to bring in the baby powder. Together with the makeup brush, I was able to cover the board with a thin layer of powder, so it's easier to scan it. The end result was pretty good, and the next day I washed off the powder with demineralized water. I tried to find the best spot for the board and eventually ended up placing it on the back of the extruder. There was just enough room around the components, and I modified the standard covers, which are shed by Prusa, to mount it. The bracket was mounted to the extruder and the board fell perfectly in place. I mounted the standard panel to the back and placed this assembly on the printer. Do you like when things are running exceptionally well and smooth? Then the sponsor of this video, Odoo, might be just for you. Odoo is a super flexible all-in-one business management platform that helps you keep all the behind-the-scenes stuff running just as smooth as your best project days. Instead of hopping between a bunch of different softwares for invoices, inventory or scheduling, Odoo brings it all together in one place. Say you're running a small workshop or managing a few projects, you can plan everything with Odoo, from your project to tracking your time with timesheets, and then automatically send out invoices using invoicing. Everything's connected, so once you update something in one app, it's synced everywhere else. Odoo helps you automate repetitive tasks, and its intuitive interface makes it easy to use. Wherever you're based, Odoo is configured based on your location, making sure your taxes, rates, etc. all comply with your local requirements. Basically, it's the kind of system that keeps your business or side projects running like a well-tuned machine, so you can focus on the fun, creative part instead of getting buried in administrative tasks. Try your first Odoo app free for life by clicking the link in the description. It comes with unlimited hosting and support, and see how it can keep your workflow running just as smoothly as this project is right now. Okay, it fits, it doesn't collide, there is enough space here for the nozzle. The location of the nozzle, it is the same height as it was with the original tool. I also think that there isn't an offset in X because it looked like it's dead center from the stool plate, and I kept it like that. But we do have an offset in the Y direction because we have some plates here and a different extruder, of course, so I cannot get it closer. This is where our problems start. No, that's not true. Our problems start with the actual load cell, because the load cell needs to trigger first. I have no idea if that works. The firmware measures the load cell, of course, and there is some sort of threshold for it to detect a touch. Because we added more flexibility to the system, I'm afraid that it will dampen it. If the probing works, then we go to the second step. Then we are already really lucky people. And the second step will be, we have to calibrate all these 5 tools, and they must be aligned. So if you're going to combine materials and colors or whatever, of course they have to align. So there is this calibration procedure. We're going to screw this here in the center. And the calibration procedure, it will move towards this rod and we'll touch it in all directions. And it does that for all the 5 tools. So that way it can calibrate it. But the problem is that we have this offset. But first I have to do the unthinkable. I have to read the fucking manual. I painstakingly read through the manual, followed the instructions and mounted all the tools to the printer. Our new tool, however, was colliding with the part that is holding up the cables. And this was a big problem. I didn't take this into account, so this means that I have to redesign. Oh, never mind. It fits now, and some zip ties also do the job just fine. Maybe you're wondering why I'm not using my grill plate printer for this project. That groundbreaking printer with the 2 independent moving gantries that I was bragging about and almost got 1 million views here on YouTube. Well, I came to the conclusion that my goal of experimenting with material combinations can be done on the XL as well, with the difference that we have 5 tools now and that it's easier for others to replicate. I discourage you from replicating this grill plate printer as it is now, and it's a bit of a miracle that it worked in the first place. I mounted all the tools to it and I'm pretty confident that it will be able to pick up this tool. I don't see any issues here, but the problem is with the next one, because there isn't a lot of space here. Or we need to modify this so that the extruder is rotated 90 degrees. Or, and I hope that that's possible, we increase the pitch between the tools. But I don't know if there are any safety measures in place. I have connected these fans to it, just temporarily, because once I start it up, it will go through a self-test sequence and it also tests if the fans work. So I just connected everything except for the motor. Hopefully it's not going to test that. And then we will find out if that load cell actually works. So, and if that load cell works, then we can move on. If it doesn't, then we have a whole other problem here. I decided to continue with this tool anyway, so we can find out how far we will get into the calibration process. At least the fence tested okay. The next step was to calibrate the ducts. This is done by manually moving the gantry to the tool and mechanically adjust the part that holds it. This way everything is aligned properly and the printer knows where the tools are exactly. It picked up the tool and the cable was getting stuck behind the metal pillar. Yes, things were off to a good start. I overlooked those cables and fortunately nothing was damaged. I zip tied those cables to the head of a screw so they won't collide with that pillar. Or so I thought.
Hey! Fuck.
Oh, good.
Shit. Fuck.
I don't see any issues here.
Dock successfully calibrated.
Godverdomme.
Yep, those thermistor cables were ripped apart. It's almost like Prusa knew I was going to fuck things up because they sent an extra care package with some parts. Fortunately, this included another heater block with the thermistor. So I replaced that thermistor and I could continue with the load cell test. If this test fails, this whole idea with using the load cell as our tool plate is not gonna work. That would be a huge downer, and a lot is depending on this now. The printer asks to tap the nozzle so it can measure if that load cell works or not. And it didn't work. I remembered from last time that this could take more attempts, so I was still hopeful.
Yeah.
The second attempt worked. This means that the load cell can detect a touch through the whole extruder. It picked up the second tool for calibration, and for some reason I got my first blue screen of death.
What the fuck?
I turned on the printer again and it gave a temperature error for that first tool.
Oh.
There are 2 thermistors on it, and after I measured the one that I didn't replace, I found out that this was also damaged. Fortunately, the care package includes 2 heater blocks. This is the last spare I have though, so I cannot mess this up any further. After all the tools were calibrated, I started that dreaded offset calibration. I came to the realization that it uses that first tool for homing all axes, including that Z axis. We already know that the load cell gets detected, but we don't know yet if it's sensitive enough to detect the bed actually touching it. I fully expected this printer to just crash the bed into the nozzle and I had my fingers on the power switch. But the damn printer just detects it. It's insane if you think about what this means.
Jesus.
Now for the real offset calibration. I screwed in that calibration pin and the printer moved the nozzle above that pin. However, we have this offset problem and the pin is never detected. I was thinking hard of how to tackle this problem. Maybe we could modify the configuration files or even move that bed as a whole. But the problem with that is that it only works when all the tools are the same. I want to use all kinds of tools, so eventually I came to the conclusion that the only option we have here is to create ourselves a dummy tool that only has the nozzle, mount that dummy tool to all 5 tools, do the calibration sequence, and then mount back that tool. This is the solution that we're looking for. I made a blank tool holder with the electronics and the load cell. We have the possibility now to mount tools to here and connect the electronics directly to the board. Leave this connected to the machine and then it should work. I can just mount this calibration tool to here. And now I'm curious how far we will get with this if the machine expects the fence to be connected. I'm afraid that it is. But if not, I'm wondering if we can just run this thing through the calibration process without this thing whining again. That would be nice. Okay, I figured out some stuff. One of them is that it apparently can detect when it's at the dock, because when it's undocked, it blinks yellow. And when it's docked, there we go. Then it's green, then it's flashing green. But we have a small hiccup. Again, there is a gap here on the side. So it's not docked well, not as well as it should be. And there is something in the way. Okay, we have an interesting problem going on here. If I'm going to park this tool, then the first thing that it will do is home, so it knows where it is. But the thing is that if it homes in X, it's not going all the way to the left, so it will crash. Yeah, so I have to redesign this part here, and then it starts whining, of course. Yeah. It took a couple of iterations, but I have a blank tool plate here that fits with the machine. I had less room than I thought, but right now it's able to home. I had to squeeze every millimeter out of this thing, and it's a really narrow package that just fits with the board. I mounted our blank tool already to this thing, but this time together with 2 100K resistors that mimic a sort of room temperature. And I was lucky that I had these thermistor cables left. I have no idea where those came from. Now the machine doesn't go into the heater area. Maybe you noticed already that some part is missing here. We don't need that anyway. And we also have room now here for adding our extruder. The plan now is to see if I can get this thing through the calibration process. And if it does, then I know that this principle works. And for the rest of the tools, I will just use the original tools. And if the whole calibration process is done, then I will modify these 5 tools as well. And then we have our system where we can add all our tools to. Even after using thermistors, it gave an error and apparently expected a heater connected to it. I took the gamble of just raw dogging a heater on there in the hope that it wouldn't turn on, just to get past that error. but then I saw smoke coming off of it. Don't connect the heater directly to an output without having some sort of cooling around it. I didn't expect that thing to turn the heater on. I explicitly selected that it shouldn't turn it on. In order for this thing to work, it needs a heater. It needs a temperature sensor, so the resistors also aren't going to work, because if this thing heats up and with those resistors, if the temperature doesn't rise, then I'm really confident that it will also give an error. We need a functioning tool on there. So at this point I might as well just finalize the design with the Proper Extruder and mount it on there. This isn't going to work. No, because then we would have that offset problem again. Then I realized I've got another Excel standing there that would make my life a lot easier. Moral of the story, just calibrate the machine with the tools that come with it. I was so focused on making that tool work that I overlooked so many steps. I was pretty annoyed with myself because I wasted quite a lot of time, but hey, this is how we learn, right? I designed the holder for the Proper Extruder using all the knowledge I gained during this project. I made this first prototype and squeezed every millimeter out of it. It uses the original part end fan and a filament sensor that we cut off earlier. How cool would it be to use this to print the first real tool? The only thing I had to do is calibrate the extruder so it prints the right amount of filament. Then I started to print and, well, see for yourself. Before we can put everything together, we need to make our custom hot ends. This time I'm using old-fashioned PTFE lined heat breaks that I had to drill out further to fit regular 4mm Bowden tubes. I drilled out the holes in the cooling block and tapped M7 thread in there. I screwed in the heat break in the cooling block and measured the total length together with the nozzle. This must be the same as the standard Bamboo hot end. The set screws keep things in place, and the next step was to add that piece of Bowden tube. The filament path needs to be fully enclosed, so I cut out a perfectly fitting V-shape and cut the tube to length. I pressed the pulleys in the coupler gears, pressed in square nuts, pressed in the bearings and pressed in the axles. I mounted the stepper motor on the back and placed the timing belts. These belts are actually gripping on the filament and makes this extruder so good at printing flexibles. After I fully assembled it, I did a quick test with the super flexible filament and this seemed really promising. I removed the prototype extruder and reprinted the rest of the parts out of the same red PETG. This is a super tight assembly, but eventually everything fits nicely. I placed our new tool on the printer and thought it would be cool to print a second tool with this, but this time in orange. Just like the other tool, it does a great job printing these parts. I removed the stock extruder from the printer and disassembled it. Just like the other tool, I removed the load cell from it and cut off the filament sensor that will be placed differently. Making the electronics fit is honestly the hardest part because everything is just so tight, but it's doable. I also redesigned the pillars with an offset so they won't collide with the tools anymore. Guess what? I'm printing the third tool with a second tool now, and again out of a different color. You will see a pattern emerging here. Yes, even the bed leveling works with the new tools. Oh, and we have this offset, of course, that places the purge line further on the bed, so yes, we do have a little less space that we can occupy. I made a different pillar for the last tool because of the offset, but this also fits well. The last step was to mount that last tool to it, and I think I just made the coolest looking printer in existence. But does it print flexible filament? Of course it does. However, it was impossible to push this wet noodle through the tube, and I made a holder for placing spools at the back, which turned out great. I had to manually calibrate the tools to align them so we can start mixing materials. The cool thing about the tool changer is that we can mix TPU with PLA that don't really stick together. Special thanks to my Patreon supporters. I haven't posted a lot, but many of you continued your much needed support. Now I have a printer that can combine these materials and I have a really cool use case for it. Subscribe if you don't want to miss that.